In this video we are planning to study about combinations. What is combination, or what is the difference between combination and permutation, if you ask. Here in combination the arrangement is not important. When you select the things or only you are selecting, the arrangement between them is not important. In the permutation, arrangement important. So when we write the combination, when we select the things with combination for the sets or for the identical things, when we talk about the identical things, or if we don't give any job to the people, we are selecting with combinations. But if the arrangement is important, we are using permutation for that one. In permutation, again I'm repeating, arrangement is not important. In combination, arrangement important. So for the combination, we are using combination n with r, or we are using this notation style, which is n over r. We are using here n over n with r, again we are using, and it is equal to n factorial over n minus r factorial times r factorial is going to be. This r factorial means r factorial different way. The order arrangement is not important. So instead of combination n with r, we can use n with r for that one. Arrangement is not important, I said. 1 and 2, when you're selecting for the set, is going to be 2 and 1, and there is no difference between them. But for the two-digit numbers 12 and 21, as you know, they are different two-digit numbers. So the arrangement important in the second one, we are using permutation here, and arrangement is not important between them. We are using combination here. And if you select with permutation 3 with 2, with combination, if you do your operation, the answer is going to be 3. If you select with the combination 3 with 2 is going to be equal to 3, and permutation 3 with 2 is going to be equal to 6. While we are doing the next operation, we are going to understand how it is. Okay, let's see. Combination 12 and 5, 7 and 2 is equal to what? Combination 12 and 5 means 12 with 5 and times 7 with 2 is going to be. And here these operations we are going to do. While we are doing these operations, the important part, simplifying the thing. In the exam, when you solve these questions, you are going to simplify only. The results exactly, they're not important for me. And 12 minus 5 factorial is going to be, this is times 5 factorial is going to be. The second one, 7 factorial over 7 minus 2 factorial times 2 factorial is going to be. And again I'm repeating this part. Here these results, they are not important for me. When you simplify them, there is no need to multiply them. We are going to understand when I solve the question, when I complete the question, and you are going to do in the exam like that. Okay, 12 factorial over 12 minus 5 factorial, which is equal to 7. So 12 times 10, 11 times 10 times 9 times 8 times 7 factorial over is going to be 7 factorial times, I'm going to open 5 times, 4 times, 3 times, 2 times 1. This is the left side. And now we are going to solve the 7 factorial. 7 factorial can be written as 7, 6, 5, because the down is 5 factorial. 7 times, pardon, not equal to sign here, is times, it should be here, times 7 times 6 times 5 factorial over 5 factorial times 2 times 1 is going to be 5 factorial and 5 factorial. You simplify 2 and 6, you simplify, it's going to be 3. So this side is 20, 1 is going to be 7 factorial and 7 factorial, you simplify 5 and 10, we simplify, the answer is going to be here, this is going to be 2. 4 and 8 you simplify, this is 2. 3 and 9 you simplify, this is 3. And 2 and 2 you simplify, these two, they are going to be equal to 1. So everything we simplified on the denominator. What we left at the top, 12 times 11 times 2 times 3, 6 times, yes, 6 it's going to be. So it's going to be equal to 11 times, 12 times 11 times 6 times 21 is going to be, and this is the answer for us. In the exam, if you write like this, it's going to be enough for me. You are going to simplify the things and you are going to write the answer only. There's no need to multiply because calculator is not allowed in the exam. Okay. Now, to understand the difference between the permutation and combination, this question is important because in this question, for an A choice, we are going to solve the question with combination, and B choice, we are going to solve the question with permutation. Let's understand the difference. Okay, for the A, there are chosen in how many different ways 2 students can be chosen from the students of 3D. We know that in 3D class there are 21 students, so we are going to select from 21 2 students. If 2 students chosen for biology project, it means that first student or second student is not important because 2 students has chosen for same job. That's why the order or the arrangement is not important for the first one. That's why we are going to use combination for this one, combination for this one, and combination when we say the arrangement, it's going to be 21 or selection, it's going to be 21 with 2, then it's equal to 21 factorial over 21 minus 2 factorial times 2 factorial is going to be, okay, this is equal to 21 times 20 times 19 factorial over 19 factorial times 2 times 1, 19 factorial, 21, and if you simplify this 2 factorial 2 times and 1, it's going to be equal to, this is going to be 10, so 21 times 10, it's going to be equal to 210. It's easy to multiply, that's why I calculate this number. But here in the second one, 2 chosen students has going to take different projects. So for biology or for physics, when you select the student, that differences going to be important. So the arrangement is important here. One student chosen for biology project or physics project, then you're selecting for physics or biology project. That's why who is taking physics and who is taking biology is important. When it is important, we are using permutation for this one, and in permutation we are selecting with this formula from 21 to 21 factorial over 21 minus 2 factorial only. The extra part in the combination, we are dividing 2 factorial, which is 2 student arrangement between them. Okay, 21 factorial over, and it's going to be equal to 21 times 20 times 19 factorial over 19 factorial is going to be, and when you simplify, it's going to be equal to 21 times 2, which is 42 times 10, which is 420. Different way we can select the students. After this question, I'm going to concentrate on the solution method of the question instead of operations here. That's why I'm going to write only the results. I'm not going to calculate the operations here in the exam, but you're going to simplify, and you're not going to multiply, but you're going to find the results of the, or the multiplication of the product of the these calculations. Okay, there are 8 fruit pieces of a different kinds of including apple on a tray. How many selections of 4 pieces of fruit can we make if we include the apple? If we have to include the apple, if we have to include the apple, means we are going to put apple already in a plate. So if we have 8 fruits, it means that we have 7 fruits, because apple already we have included, already chosen. So if apple already chosen, it means that from 7 you are going to select only 3, because it says that 4 different pieces. So From 7 you are going to choose 3 because one of the piece already chosen, again the apple one already chosen. So from 7 3 you are going to select, this is going to be 7 factorial over 7 minus 3 factorial times 3 factorial is going to be. Okay, now we are going to continue with the new question. There are 10 players in a list. A basketball coach will choose 6 players from the list of a school team, for a school team, sorry, and make one of them captain. So there are 2 actions here. First, to select 6 person, and then to choose one of them captain. In how many ways coach form the team? As you see, the jobs of the, or the playing places of the basketball team is not written here, so anyone can play in any place. So we are going to select from 10 6 of them, and we are going to use the arrangement is not important. We are going to do like this, but after that one we are going to multiply by 6 because one of them selected as a captain. So we are going to select the captain from 6 player 6 different way, and the answer is going to be 10 factorial over 10 minus 6 factorial times 6 factorial times 6, it's going to be, which is equal to 10 factorial over 4 factorial times 6 factorial times 6 is going to be. Okay, in a group of children, 9 children, 4 children will be given apples, another 3 children will be given oranges, the rest will be given peaches. So here we are going to give from 9, first we are going to give 4 apples, then we are going to give 3 oranges. For the identical things, all they are going to be apples, so the first, second or third or fourth is not important for us. Who's chosen firstly? Only selecting 4 children is important. That's why we are going to use the combination for this one. Okay, from 9, first we are going to select 4. Then when you give the apples, you are not going to give them another or on another fruit. That's why they are not going to be selected. Then you had 5 more, and from 5 you are going to give 3 oranges to the children, and the left 2 we have, and from 2 of them you are going to give. But we need to know this one. If you have 2, and if you are going to give 2 of them, so you are going to select 2 of them, it means that you are not selecting anything here. And when you calculate also, you are going to see the answer of this part is going to be equal to 1. So 9 with 4, 5 with 3 times 1 is going to be our answer. Okay, the next one. A cafe offers chocolate, lemon, sour cherry, and vanilla flavors of ice cream. A customer can choose 1, 2, 3 scoops, but the flavors must be all different. How many different possible ice creams can a customer order? Now, in this question, we are going to calculate one by one, because to select 1 and to select 2 cannot happen together. A customer can choose 1 scoop or can choose 2 scoop. These 2 cannot happen together. That's why we are going to use addition also here. And when you select the scoops, you are going to select without order. Order is not going to be important. First is chocolate, then lemon. It's not going to be important for us. That's why we are going to select with the combination. So I can write like this. From 4, we can select one of them, 1 scoop. From 4, you can select 2 of them, 2 scoops. From 4, you can select 3 of them. And this is going to be the answer of question. And when you do this question in the exam, if I ask, you're going to simplify these things. Okay. Now, in this question, we have 2 classes. 3b 3d, and in the classes there are 22 and 21 students, and we are going to form a basketball team, 5 players, 2 students from 3d and 3 students from 3b is going to be. Okay, then we are going to select with combination because the order arrangement is not important. So we are going to select from here. As you know, in 3b there are 22 students. From 22 students we are going to select 3 students, and from 21 students, which are the members of the 3d, we are going to select only 2 students for the basketball team, and totally 5 players we have chosen, and it is not mentioned they are going to play in any place. That's why the arrangement is not important between them. Only selecting 3 students is important here. Okay, in this question there are 8 students, and we are going to select 5 of them for the circular table and 3 of them for the bench. So how many different ways we can do this one? Firstly, we are going to start with to select with for the circular table. So from 8 we are going to select 5 of them for the circular table, then 3 of them left, and circular for the bench 3 from 3 we can write, but this answer is equal to 1, and there is no need to write that one. Then times. Why times? Because the question hasn't finished. Student be seated in the room. How many different way? So it means that we are going to select 5 students, and then we are going to put them around the circular table. How many different way they can sit around the circular table? If we ask, the answer is going to be 5 minus 1 factorial different way they can sit around the circular table. If you remember, n minus 1 factorial different way, and n people can sit around the circular table is going to be. Then we arrange the peoples 8 with 5 and 4 factorial times 4 factorial. It's going to be. What about the other 3 people? Of course, the other 3 people, they are going to sit on a bench 3 factorial different way. This is linear permutation. That's why it is not. We don't have n minus 1 formula for that one directly. N factorial different way is going to be.